Welcome to Physics, Center of Mass, Session 1. Aim of today's topic is to introduce the concept of center of mass and to find the position of center of mass for system of two particles as well as system of multiple particles. First of all, let us understand the concept of center of mass. To understand the concept of center of mass, let us see the throw of an Indian club. What did you notice? See, when the Indian club is thrown from here, there is a point inside the Indian club. Initially, this point was here. The handle of the club is rotating around this point, and every particle of this Indian club will be moving in different directions. But this point inside the Indian club will move along the line which is shown. It's a parabolic path, correct? So see, at this point I have shown you by a red dot at this position. See, as it moves forward, how does it look? Now see, the handle of the Indian club has rotated, but this point remains at the same. See, here also. See, at this point. And as it goes down. So the point of Indian club is moving like this. Check again. So what did you notice? For every body there is a point which is the leader particle, or that point will be such that all the particles of the body will move around that point as if that point is leading. This point in the body is called the center of mass. The center of mass of a body, or we can also call system of particles, is defined as a point at which the entire mass of the body is supposed to be concentrated. So center of mass of a body is defined as the point at which the entire mass of the body is supposed to be concentrated. So this is the point as shown in here. That point is moving as if the complete mass of the body is concentrated here, and every particle is moving around that particular particle. So did you follow this point? This point is called the center of mass. So remember, whenever an object moves, it moves in the same way as a point mass of the mass of the object would have moved. Then this point mass, we can represent it as center of mass. The center of mass of an object is the point associated with the system that move in the same way as a point mass having equal mass or having mass equal to the object would move when subjected to an external force that acts on the object. Therefore, the motion of the system can be observed as the center of mass alone. In this case, the Indian club which is there at this position here, now it is positioned like this. The handle is moving in a different direction. We can assume like this. This will be positioned this way. So the handle is going to move in a different way altogether, whereas it will be moving like this, and finally it will be coming to this position. But this point will be always moving as if it is moving about this particular point. This point is the center of mass inside the club. All the particles move about the center of mass. This point you should note. All the particles move about the center of mass in different directions, but remember, they follows the center of mass. Any external force acting on the object will be as if it is acting on center of mass, and the object will move with the acceleration of the center of mass, right? So for every body there is a point like that about which all the particles of the bodies are going to move. It can be converted into a point mass. Suppose I convert the big body into a small particle. That particle, given the mass of the body, then in whichever direction that particle is moving, we call that is the representative particle, or that is the center of mass. Center of mass of a body or system of particles is defined as a point at which the entire mass of the body is supposed to be concentrated, and then when the object moves, it moves in the same way as the point mass of the mass of the object would have moved. That means if we give this point mass as the mass of the object, then whichever direction the point mass moves, the object also will move like that. Say for example, in case of a car, when car is moving from one point to another point, you see very carefully, the tire of the car or the wheels of the car, they are going to move like this. Whereas the engine is going to move, or particles of the engine moving in different direction. But there is a particle or there is a point in the car which is moving in a translatory motion in a straight line. This point is called the center of mass point, where the total mass of the body is concentrated. That means we can convert this car as a single point, and we can say car is moving from point A to point B, and the complete mass of the car is given to this point mass. All the particles move about the center of mass. This point is important. They follow the center of mass. They move in different direction but follows the center of mass. Any external force acting on the object will be as if it is acting on the center of mass, and the object will move with an acceleration of the center of mass. That means this big body we have converted into one particle. This is the center of mass particle. Now, if we can calculate the acceleration of this particular particle, that will be the same acceleration as if it is given to a body when an external force is applied. The force can be applied on the body at any point, no problem. But it will go as if it is applied on the center of mass particle, and the center of mass particle move from point A to point B. So that means anywhere the force applied on the body will be as if it is applied on the center of mass particle. So this is actually, we can call it as a representative particle or a leader particle. This is the particle where the total mass of the body is supposed to be concentrated. Let us see one more example of center of mass here. Here we have a bomb. If it moves in the forward or thrown with a velocity v, it moves in a parabolic path. But as it goes to the topmost position and explodes, the particles will be going in different directions. But the center of mass particle will continue to move in a parabolic path, and all the particles after explosion also will move as if they are moving about that particular point. Let us see. Did you follow this point? Let us see again. Now the bomb is moving actually in a parabolic path. Now here it is going to explode. Now explosion, every particle is moving in a different direction, but they will move as if they are following this center of mass. So the bomb is moving about this particular point. Here it explodes and it breaks up into many pieces. One of the piece may fly here, another piece flies here, another piece flies here. But still the center of mass will move like this. There may not be any particle at the center of mass, but these particles will move as if they are moving about this particular point. So remember this point also. Position of center of mass lie within or outside the object. For example, in the case of a disk, it is at the center. In the case of a ring, it is at center, but there is no material at the center. So we can call outside the material. In this case, till the bomb is as a single piece, center of mass within the body. Here, every particle is moving in a different direction. But the center of mass is moving like this. There may not be any particle at the center of mass. So center of mass can lie outside also. All the particles will move as if they are following the center of mass, where there may not be any particle at all. This center of mass, remember, if we calculate the position of center of mass is independent of the coordinate system. Independent of the coordinate system chosen. So whichever coordinate system we choose, the center of mass will follow, because all the particles are moving about that point will be there only, and that particle will move, or the point will move as if all the particles are moving about that point. So it does not depend on the coordinate of the center of mass. So in the two examples what we have seen just now, one is in the case of an Indian club where all the particles are moving about that point. Another is in the case of a bomb where the particles have exploded and started moving in different direction, but the center of mass continued in the same direction, although there is no particle in that particular line. So this is a point in space. So finally we can say center of mass is a point in space where the entire mass of the body is supposed to be concentrated. Remember, it is different than the center of gravity point. We will study in more detail about center of gravity, we call CG point. Center of gravity is the force applied by gravity on the body, whereas center of mass is a different point. It is a point in space where the entire mass of the body is supposed to be concentrated. Remember this particular point. Now I think you followed what is the center of mass